Hello, konnichiwa minasan, mambo desu. So today let's start with a new subject called dynamic programming. Okay, so here's our problem. We must climb n steps, and for each time we can climb 1, 2, or 3 steps. Then how many ways to climb n steps? So first we need to visualize the process. Okay, so let's so first for example, if we need to climb 4 steps, here one, first let's draw 1, 2, 3 and 4. If we climb one step, then we will reach step 2, and from there we can reach step 3 and 4. And if we climb 2 steps, then we can reach step 4. So it appears that from this, from the 4th step, we can climb 1 step from 3, 2 steps from 2, or 3 steps from 1. So yeah, so and from 3 we can climb 2 steps from 1 step from 2, or 2 steps from 1, and from 2 we can climb 1 step from 1. Yeah, so it's okay, so let's visualize. Okay, so from 4 we need to find a way to, we need to count the number of ways to climb from step 3 and step 2 and also step 1. Three, 2 and 1. Since okay, so since for each way we climb to step 3, we can always just climb 1 step to step 4, or we climb 2 steps to step 4 or 3. So okay, so let's get with this problem. So in order to find how many ways to climb from step 3, then we can climb 2 steps from 3 steps from step 1. Okay, So to climb from one, there's one way, and from one there's one, two. You can climb, count the number from this, the one or zero. You go to two, and from three you can count the number from two, one or zero. So 2 plus 1 plus 1 equal to 5, and 4 you can keep the same. So 5 ways to reach 3, and then move one step, then 2 ways to reach 2, and then move no. So the problems are overlapping. Okay, so let's try again. One, two, three, and 4. And to first, we want to count how many ways to reach 4 from. So okay, so there's one way to reach 4 from 3, one way to reach 4 from 2, and come up with how many ways to reach 4 from 1, 2, and 3 from every other step. Okay, so to reach 4 we can reach 3 and move one step. Okay, so in 3 we can only walk one step to reach 4. In 2 we can walk either one step to reach 3, which contributes to 3. Okay, so let's just try the ways to reach this number by okay. So we can go to 1 or 2 or 3. Okay, and when we go to 1, from 0 we can go to 1, 2 or 3, and from 1 we go to 2, and we have the same number of ways to get to 4. Okay, so we should go backwards. One we can also go to 3, and 1 we can go to 4. Okay, so let's try backward to know how many ways to go to 4. We can get how many ways to go to 3, how many ways to go to 2, how many ways to go to 1. No, they're not overlapping at all. So to go from 3 to 4 we need 1 step. 2 to 4 we need okay, so to get to 2 to 4 we need we can either go to a 3 and then repeat the same action as going from 3 to 4, or we can just jump straight to 4, and here from 1 I can go to 2 and repeat the same action as going from 2 to 4. I just go straight to 4, so it's just in 1 to go to number going to 4 from 3 is just 1, from 2 is this one plus 1, and from 1 it's you can number you can either get the number to go to 2 from 4, so 1, okay, so to if we go from 1 we can go right to 2 and repeat the same number of problems, get the same number of ways to solve this. Okay, we go to 3. Okay, so if we go to 2 then we can then we just take the same solution from 2, but in 1 we can also go to 3, so we can take the solution from 3, but this also overlaps with 2, so okay. 3 to 4 just 1 step, 2 to 3 still there's one way to go to 3 to from 4, go to 4 from 3, and to go to 2 from go to 4 from 2. We can either go to this, go to this and count the number of ways to go to 3 from 4. So it's just become 2 count 3 plus if we go to jump directly to 4, then plus 1 way equal to 2. And okay, from 1 we can either we can either jump to we jump to 2 from 1. If we jump to 2, then we can get the solution from 2, which is 2 ways. Or we can jump to 3, and we have to 2 plus equal to 3. Okay, so here going from 3 we have 1 way, going from 2 we have 2 ways, going from 1 we have 3 ways, and plus 1 is 4 ways. We jump directly to 4. And from 0 says we either jump to 1, to 2, or to 3. So 4 plus 2 plus 1 equal to 7. So okay, we take the number of ways to go to 4 from those numbers. So that makes sense. So the base case is that we are at 4, and there's 1 way to go to 4, and okay, so let's try. Okay, let's get started. Let me start the timer. So okay, here we are at let's input the data and okay, so we need to count the number of ways to go from n to okay, to go from 3 to 4. From plus 1 ways to reach okay, and for the base case let's get it to 1. We will start from equal to 3, nope, and -1. We need to count the ways who will reach the next stage. Okay, so if 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 we can jump immediately to the number, then that okay, we can. So if we reach n immediately, we can get that count. So ways to reach from I will be equal to if I for it, we can jump 1 step or 3 steps. If I plus j greater or equal than n, then that means we overstep. Then ways to reach I plus equal 1, and we break, otherwise we can get the ways to reach at I plus j. Jump to pass destination, then one way to get to that so okay, and we iterate until we reach I equal to 0, and at this point we can count the number of ways to reach the destination by okay, we also need to modulo the answer. We need cos mod equal to +7. Okay, and okay, at the start we will know that cos in. Okay, so this is the solution. We can count the number of ways to reach the end by copying the number of ways to reach it from the later step. Yeah. So when we are at 1, we can copy the ways to reach 4 by when we are at 2 or when we are at 3. And yeah, since there is just 3 options, is that we at 1 we jump to 2 or we jump to 3 or 4. So we can optimally copying the step to go to the final state. Yeah, and let me try submitting the solution. Okay, okay, accepted. This would be a simple solution. And yeah, let me pause my solution. Okay, thank you. See you.